From the given system of linear equations, we can write the augmented matrix as follows. The coefficient of x1 in the first equation is 3, coefficient of x2 is -2, and the constant is -1. Now let us write the second row. The coefficient of x1 is 4, the coefficient of x2 is 5, and the constant is 3. So third element is 3. Now third row, the coefficient of x1 is 7, the coefficient of x2 is 3, and the constant is 2. Now look at the second example. The coefficient of x1 in the first linear equation is 2, x2 is missing, therefore let's write 0. The coefficient of x3 is 2, and the constant is 1. Now let us write the elements of second row. The coefficient of x1 is 3, the coefficient of x2 is -1, the coefficient of x3 is 4, and the constant is 7. Now from the third linear equation, we'll write the elements of third row. The coefficient of x1 is 6, the coefficient of x2 is 1, the coefficient of x3 is -1, and the constant is 0. Now look at the third example. In third example, three equations are given, and from all three equations we can say that the system of linear contains three variables x1, x2, x3. In the first equation, the coefficient of x1 is 1, x2 is missing, therefore we'll write 0. In first equation, x3 is missing, therefore we'll write 0. And at last, the constant is 1. So the elements in the first row are 1, 0, 0, 1. Now look at the second equation. x1 is missing, therefore we'll write 0. The coefficient of x2 is 1. x3 is missing, therefore we'll take 0. And the constant is 2. Now look at the third and the last linear equation. x1 is missing, therefore we'll write 0. x2 is missing, therefore second element is also 0. x3 is there and its coefficient is 1, therefore we'll write 1, and the constant is 3. This is how from given linear equations we can write the augmented matrix.